crater. So pretty exciting to see one at Meridiani. So here we are. There's a long way to go. This is our current location. You can see all of those sand ripples. But what you can see is we're sort of in the middle of a long ripply plain, and there's a lot more of it. There's where we are. Here is our driving terrain. Well, let me end just with a sort of real preview of some other missions. MER was not the last mission to Mars. In fact, it wasn't even the most recent mission to land on the surface of Mars. Phoenix, which was built from the 2001 Surveyor lander, landed on Mars, went back to the idea of a rocket-powered lander, also a solar-powered mission, used these ultraflex solar arrays, a very lightweight solar power system, landed for the first time very high in the northern hemisphere of Mars, not quite on the polar cap, but definitely within the Arctic Circle. That is very interesting terrain. Here's the orbital view of the Phoenix terrain. The Phoenix terrain is filled with these polygons. This seems to be the cracking that you get from freezing and thawing, repeated freeze-thaw cycles. For the first time, we landed in this terrain, and actually we could look down and see ourselves land. This big crater is a little bit misleading. That's way off in the distance. We're looking sideways, and that is just miles and miles away. But if you look very carefully, you see that little dot, and that's Phoenix landing on the parachute. So here's the parachute. There's the Phoenix lander shortly before it cut loose of the lander and turned the parachute and turned on its rocket engine to land. So here's Phoenix on the surface. There's the solar arrays and digging down on the surface. And the most interesting part about it is right underneath it, where the rocket engines had blown away the soil overburden, you see the white stuff that certainly looks a lot like ice. In fact, it sublimates away at ice melting temperatures. So it does seem that at this landing site, right under the surface, we're getting some ice. I should mention, by the way, that this is not my mission. I'm just sort of briefing to, because I think it's cool, actually. Phoenix was a limited lifetime mission. Unlike MER, it landed in the polar regions where you don't just get less sunlight, you get no sunlight during the winter time, and it also got covered by a couple of meters of ice. So it looks like it pretty much got crushed by the ice in the middle of winter. But it's not the end of Mars exploration. Here's the next rover to go to Mars, Mars Science Laboratory, called Curiosity. It's actually twice as big as Spirit or Opportunity in all directions. It carries 10 times as much of a science payload, and it will be landing on Mars in the largest planetary aeroshell ever built. This aeroshell is bigger than the Apollo capsule. And in fact, for the first time, we will have the capability to defend ourselves. Because it has a laser vaporizer death ray on it. This death ray is capable of drilling holes in rocks. In fact, it was actually designed to drill holes in rocks. It has an interesting method of landing. In fact, it lands via this technique of having the rocket lander hover overhead and lowers the lander down on a cable. That'll be pretty interesting. I'm really interested to see that. There's a view sort of what it will look like. Beyond that, their Scout mission has been canceled for the future, but the Scout missions that are in the pipeline are going to be flown. This is an atmosphere explorer. We're going to find out about the atmosphere of Mars. And the Russians and the Chinese are flying missions to Mars. So this is the Phobos Grunt mission, which, if everything works correctly, will actually bring back a sample from the moon of Mars, Phobos. That's actually pretty exciting. I haven't had time much to talk about the moons of Mars, but they're actually really interesting places. There's a lot to be said about Deimos and Phobos. Beyond that, NASA's collaborating with the Europeans on a mission called Exomars, another rover. hopefully, we're going to ultimately do a sample return. So this is sort of what the program is designed for. But that isn't actually the mission that we're all here for. This is the one that we're here for. Ultimately, we want to send people to Mars. That's our goal. That's my goal, anyway. Move on out to Mars, break into Mars orbit, and maybe go to Mars, sort of find some old friends, dust them off, and say, hey, how would you like to come home to a museum? Some later ideas for a Mars rover, a big Mars rover. Here's an interesting European concept. Here's this is a different European concept for a Mars rover. There's a lot of proposals that we might be able to balloon on Mars, but this is the one I want. That's me. That's me right there. That's me. This is I call dibs on this Mars rover. Might be able to look at some of the interesting spots on Mars. These are places you'd probably want to drive to, not necessarily land at. Sort of look at some dust storms. Maybe even do some extreme exploration. Here's the people rappelling into the Valles Marineris, the Grand Canyon of Mars. I show this image and I usually say, well, you know, I wonder who the safety officer on this mission was that's permitting this activity. And then I always say, well, I'm a real hypocrite because I'm also a science fiction writer. In my novel about Mars, Mars Crossing, my astronauts do exactly this. They rappel down into the Grand Canyon of Mars, the Valles Marineris. And this is a cliff that's a vertical cliff about 1 mile high. You don't want to fall. But, you know, my characters had to. I made them. I'm the author. I can make them do things like that. But, of course, an important thing about Mars exploration is you do need to make your propellant lift off of Mars, perhaps rendezvous with a Earth return vehicle, and the last part of a Mars mission is the safe return home. So let me leave you with a couple of websites. Here's the Mars rover website. Good websites, the Planetary Data System, Planetary Information. And if you want to know more about me, here's my website. Plus, my agent told me that every time I give a talk, I have to remind people that I also do write science fiction. So here's a couple of my books that you could go find from your friendly local bookseller. And with that, I think I have just barely kept on to schedule, even though I started a little bit late. So we may have time for 1 or 2 questions. Sure.
That the MER rovers do about 1 centimeter a second. I was wondering what Curiosity does or will do. And also, if you have some idea of what the average distance traveled between starts and stops has been for the rovers.
Yeah, Curiosity's not my mission. I was under the impression it went about 3 times as fast as the MER rovers. The MER rovers actually average more like half a centimeter a second. They go pretty slowly. A lot of that is because they have to think. They really have to look and see what's up ahead, make sure they don't run into anything. The wheels on Curiosity are more than twice as big as the Spirit wheel, and that means that it can traverse over much rougher obstacles. It can pretty much not worry about things that we look at and say, no, we need to drive around it. These days, on a good day of driving, we get about 70 meters. When we were doing the long drive across the plains toward Victoria Crater, we were actually going farther. I think our record was more like 170 meters. And they do auto-nav driving on that. First the rovers would drive it for as far as they could see, the drivers, and then they'd say, okay, auto-nav yourself, find obstacles, pick your course, drive as far as you can, and then tell us how far you drove. What we discovered, though, is that one day we hit one of these little dunes wrong. And the auto-nav kept running the wheels because it didn't know that it wasn't moving when it ran the wheels. And it drove what it thought was 50 meters, and turned out it made about half a meter of progress, and what it really did is embedded itself in. And it took us over a month to back out of that embedding. So what we ended up doing is we started turning on visual odometry. So that means that the camera takes a picture, and when we move, we make sure the picture is changing, that we're not standing in place and spinning the wheels. Unfortunately, that takes a lot more computing time, so that's what we call a slip check. So we only drive so far before we slip check. That takes a lot of computer time, so it means that we can't do these 150-meter drives anymore if we're checking for slip. So 50 meters is a pretty good drive these days. Occasionally we get a little bit more, and that's per day of driving. And we don't drive every day. In fact, it's midwinter. Rovers are a bit dusty. At best, we drive every other day. But that's good because it gives us time to actually look at the pictures before we go on to the next drive.